I'm really lucky to be sitting here right now with Alex Hidalgo, who educated me quite a bit, both with his book and from having talks with him in the past about really cool topics on SREs like SLOs. And I mean, honestly, I think you are definitely one of the foremost, if not the foremost experts on the topic. So I was hoping maybe you could tell me a little bit about yourself.
Yeah. First, thanks so much for having me. Yeah, I stumbled across this career actually. Funny enough, I worked at an IT help desk company on the other end of this block
Oh,
of
nice.
where we're sitting right now. I was just, to me, it was just a job. I was just doing desktop support. But I happened to have a big interest in Linux and networking.
Mhm.
So I was relied upon for some things that weren't just, virus scans and things like that. And then kind of almost by accident, I ended up at this company called AdMeld, which was then acquired by Google. And suddenly I was a site reliability engineer. And I didn't even know what that really meant at first. But then I read this doc by Dave O'Connor called Bad Machinery. It's all about thinking about the humans,
Mhm.
right? It's thinking about how you can make things better by ensuring that all of your thoughts take the human components, both the customers and the engineers, into account with anything you do. And it was really there that I became very interested in my career, as opposed to doing it just to pay my rents and just be able to eat,
Yeah.
right? And that's when I became really interested in how can we in the technology industry
Mhm.
think about things in a way to make people's lives better.
Oh, that makes a lot of sense. I started in help desk too, but I don't think I took the same path that you did. I ended up moving on to things like administration and then actually systems engineering, which I think was kind of a precursor to what a lot of people view DevOps as. This was about automation, and I kind of view it as the application of levers in compute world where I don't want to have to do this 50 times. I'll write code to do it. So that to me was kind of a really big thing in kind of elevating my path in my career to saying, I don't have to do this 50 times. I can just write it once and maintain it forever. That's perfect.
Right.
Yeah. So while I have you here, I was hoping I could ask you a few questions. I know you have a couple of, I'm just going to refer to them as maybe a little contrary takes to how some people are doing SRE these days. And specifically, I wanted to talk to you about what your thoughts are on things like mean time to restoration of services, mean time to detections, because I know you have some interesting opinions and I absolutely respect the heck out of them. So I wanted to hand it off to you on that.
Well, thank you. Yeah. I have a few problems with current kind of modern SRE, and the primary first thing I think of is just the fact that the term is become very diluted, right?
Yes.
At Google, it was where I spent a long time. It really had a relatively strict, definition. It was also flexible, of course, because different teams need to have different focuses and need to think about different things. But my biggest qualm with site reliability engineering today is that a lot of corporations, after the first Google book came out, just kind of were like, oh, we're going to do SRE now. And they just slapped that title on everyone that was doing traditional operations work, which, by the way, there's nothing wrong with doing traditional operations work, but they just slapped the title on everything, which is kind
Yes.
of diluted what a reliability engineering approach to things really means. The reliability engineering did not start at Google or in the software industry at all, right? It goes all the way back to the US military in 1947, I think it was, is when the term was first coined, and it has a long tradition of, measuring things correctly, right?
Mhm.
The term reliability in this sense really means, is this thing doing what it's supposed to be doing?
Okay.
And that applies to many things outside of software systems. It's not just for SaaS, right? Um, but it's been brought into our industry, and I think it's a very useful practice because it can help you be proactive as opposed to reactive. And one of the other big issues is that people are still stuck thinking in like the ITIL world, right? They're still stuck thinking
I'm
about
ITIL
things.
certified. I know it very well.
Okay,
Yeah.
yeah. Which again has good aspects to it, but it kind of encourages a way of looking at measurements and telemetry and monitoring in a way that does not reflect the proper way to think about modern reliability systems.
It teaches you how to respond effectively, but it doesn't teach you how to think correctly in building the thing in the first place.
Yes. And it's not good at helping you learn from things. Right?
You're just, I think ITIL has this focus on, we're going to continuously improve, but I don't view it as kind of learning from the past and improvement. It is, we're going to try something new.
Right.
Whether it's good or bad, we're going to do something new again.
Yeah, which in many aspects of our industry might be the right move, right? Yeah. But especially when it comes to things like outages and incidents, and as you mentioned, mean time measurements, right? So software is not perfect. Like anything, it is going to fail at some point in time. And you just want to make sure it's not failing too often, right? Yeah. Essentially, you want to find the balance in between retaining your customers and growing your customers and ensuring you're not losing them. Because if you try to be perfect, well, no one really needs that anyway. And also you're going to spend too much money, either literally in finances for paying for extra replication of your services and your data that you may not actually need, or having to hire more people, right? People are very expensive. Training people is very expensive, and so you need to shift that focus to how good do we have to be, right? And so people start thinking about outages and they start thinking about incidents, and where they start is very often they start counting them, right?
Yes.
But if you have, let's say in Q1, you had 20 incidents, and then in Q2, you had 10. Awesome. Everything's better. The OKRs we set to track the number of incidents, like everything's great. But let's say that in Q1, the total outage time of those 20 incidents was 120 minutes, right? 2 hours. And let's say in Q2, those 10 incidents, the quarter where you performed better, are like 150 minutes, right?
Yeah.
Well, okay, so you're not telling the right story.
No, you're collecting data, but you're getting the wrong thing out of it.
Right. Yeah. So then, generally speaking, people will introduce like severity levels, right? Okay, this is the difference in between a SEV 0 or a SEV 1 or a SEV 2. And they like to think that that helps them categorize things correctly. And then, And
then they fight over whether it's a real SEV 1 or not. Is it a SEV 2? And you're wasting time.
Exactly.
Yeah.
Exactly. And what do you do with an incident that's technically by your buckets, by your defined documents that you distributed to like the entire company? What if it's technically a SEV 2 for 2 hours, but it's technically a SEV 0 for 5 minutes? Does that make that entire 2 hour long incident a SEV 0 or a SEV 2? Or do you average it and become a SEV 1? It just doesn't actually work.
And what happens if you're only impacting just your biggest customer? That doesn't count because it's not hitting the right box.
Right.
Yeah.
Right. So then people realize that severity buckets don't really work. And then where they often move to is what I refer to as MTTx, right? Yeah. Mean time to something, mean time to respond, resolve. There's so many different mean time to failure. There's a ton of different definitions here. And there's nothing wrong with the concept of mean time measurements for systems that generally perform in the same way, right? Basically, you need a normal distribution or something very close to a normal distribution for a mean measurement to tell you something. So it's great for something like hardware failure rates, right? Yeah. Let's say you have tens of thousands of hard drives that you're buying all at once. It's a meaningful measurement for that. Yeah. But computer incidents are almost, by definition, unique, right? They never have the exact same shape.
Unless it's a repetitive thing that you just haven't figured out yet. Yeah.
Maybe, but even then, you're still going to have who's responding to it,
That's
right?
True.
So if you have a more senior engineer who knows exactly how to solve it, responding to it, that resolution time is likely going to be less versus a junior who just started on the team, or the time of day that the incident happens. You're going to have a quicker resolution time, even if the incident in many other ways is almost exactly the same.
It failed the same way, but it's who's there now. Yeah.
Sure, right. It's going to be much different. Someone sitting at their desk, not having lunch, it's 3 p.m., they get the page and they can instantly start on it, versus that exact same or extremely similar incident occurring at 3 a.m. and the person being paged
a cold dead sleep, yeah.
So
I've been there. I've done that.
yeah. Oh, same.
I'm not awake for the first 5 minutes. As far as I'm concerned, it's zombie in the keyboard until I figure things out, and I've got a whole slew of people on the call waiting for me to go. Yeah, I don't know what's going on.
Right, but that's so, that's why these kind of incidents that need humans to respond to them, right?
Mm-hmm.
So hardware failure, hardware just fails.
Yeah.
But our software service incidents and outages are unique because of the human element,
Mm-hmm.
right? These are socio-technical systems.
Yeah.
They're not just computer systems. And so, there's many other examples like we could give, but that's the easiest just to say, like, even if the incident appears to be the same, your resolution time, whatever your mean time measurements are still going to be different depending on a million different factors. Even if that very senior engineer who can solve it in 5 minutes, what if they were out to lunch? It takes them time to walk back to their desk to even begin to resolve things. So this gives the distribution of your incidents, especially because they're not all going to be the same, it doesn't follow a shape where a mean time really tells you anything at all.
Yeah. So I have a question for you. This is working off of sort of a real world scenario for me. And that was, I once worked at a place where they were measuring mean time to resolution and the number of incidents that had happened within a given time frame. And what their answer to this was to say, for whatever group had incidents and was not working them back by a certain percentage, their funding would be cut. What do you think about that?
It sounds absolutely terrible to me. The problem there is that sometimes you need additional funding to even resolve these things quicker in the first place.
Or
right?
you start getting what I saw, which was gamification of incidents.
Yep.
And it's like, once you start measuring the wrong things, the game is on.
Yeah.
And you're going to have people who are going to start working toward the goal of making the game better and not making the system better.
Yeah. People will end up being afraid of what leadership thinks and will then end up, as you say, like gamifying it, right?
Yeah.
They will start having different definitions of incident start time and incident end time, right?
Yes.
They will start doing whatever they can to bring those metrics into line with what leadership actually wants, as opposed to actually improving their processes.
Yeah, well, it's also when you reward the wrong things, when you penalize the wrong things, the actions have consequences. And it's, are you familiar with the story about what happened when they wanted to bring, I think it was cobra heads. You got certain number of cobra heads or tails, and they said, hey, every time you bring us one of these, we're going to give you a certain amount of money. And instead of killing cobras,
they started breeding cobras.
Cobras. And when they got rid of the program, they released all the cobras, which made things even worse than they started.
Right.
So I feel like that's one of the problems when you're trying to make things more reliable. If you start rewarding the wrong behavior, you're going to see bad behavior become more apparent.
Yeah, totally. And I've seen this firsthand in many organizations, both ones I've worked in, as well as, as someone who consults and works with the community, this is a very common pattern for people to have. And people become disincentivized of actually caring about the reliability of their services. They're like, all right, well, my primary job is to ship features. So I'm going to work on whatever's in my sprint. And I don't care if things are actually running well or not, and then that eventually will impact the company's bottom line. And, for better or worse, companies exist to make as much money as possible, right? And trying to force people into that kind of bad pattern is going to eventually lead to worse returns.
Now, do you think that it makes sense? I know we've talked this kind of thing here about shift left. Some people believe that you should bring developers to SREs. I kind of take a different approach, which is I think that in having that discussion with people about building features, you should bring somebody who has a reliability focus to the beginning, because oftentimes an SRE's job is made more difficult because they're brought in after the feature release has already been solidified. Where do you think that should play into when SREs are brought in, or should they just be part of the team in general?
I think that really depends on your organizational setup and what things look like. I think you absolutely need to bring in that reliability expert early, right? Whether that is someone who's just helping review the early design docs before things are actually built, whether it's embedding an SRE within a more strict software engineering team, or having an entire SRE team that's paired up with an entire suite team, right? Like when I was at Google, for example, many of the larger services had an SRE team that complemented a software engineering team, right?
Okay.
They would often sit next to each other, which is great. It's kind of like the DevOps philosophy, right? Like let's bring dev and ops closer together. Let's make sure that they're working together. And that's great if you have Google money, but not everyone can afford to have, like a 12-member, engineering team and a 6-member SRE team. That's a lot of people, right? Yeah. So that's one approach. But also, what I've seen work really well is the embedded, like SRE model, which has experts who understand how to think about and what things to watch out for in terms of the design of products or even just features. And they work with that team directly to ensure that they're thinking about the right things and reviewing code.
And I've seen it with security too, where sometimes security is a bolt-on after the fact, and you can usually tell when that's been the case.
Yes. Yeah. Whatever it is, you want to have that expertise at the beginning, right?
Yeah.
Even if it is just, so to go back to Google again, at least while I was there, design docs, blue docs they were called there, needed an SRE to help review, as well as the production readiness review, the PRR, which was a process you had to complete before you were allowed to actually ship a new feature or a new product out. SRE had to be involved with that review process to ensure that people were thinking about it.
You used a word I'm not familiar with. What is a doc?
Doc?
I'm joking. I've seen where it's like the code is self-documenting. I don't need to write any documentation, or we don't need to worry about this. And the one I absolutely love is when you do, okay, let's do a root cause analysis so that we can learn from this. And then you take that and you file it away into some tool, never to be looked at again. It's like the end scene of Indiana Jones, where it's just like, it's put on a shelf. You're never going to look at this again. The problem happens again and goes, I remember back in the olden days, we saw this again. It's like, that was 3 weeks ago, buddy. Come on. It's like, well, where is the RCA? I have no idea. We never look for those again. Let's go and do this. Let's interrogate this all over again.
Right.
Yeah.
Yeah. Someone who will watch this later will skewer me if I don't mention the fact that there are no root causes. There are only... there's always many factors.
There's only happy little accidents, or that's just a painting thing?
There's always a confluence of things that lead up to like any sort of failure. But like that being put aside, a big problem a lot of organizations have is they don't have the strong kind of learning from incidents culture, right?
Yes.
Like you said, they may even perform an RCA, a postmortem, an incident retrospective, whatever that organization calls it, and then no one ever looks at it again.
Yeah,
right?
and it's also one of those things of, when we're talking about this, if you're going to play the blame game, this is why I'm a big proponent of blameless cultures, which doesn't mean that it's not somebody's fault per se, but it's, you try and make sure that it's not, like you said, skewering somebody for doing the wrong thing. I think that it makes a lot of sense to make sure that people feel safe and being able to talk about what really happened. Otherwise, that gamification becomes a cover-up.
Yeah. So people will stop reporting incidents at all.
Yeah.
Right. You need to make sure that your company and your organization provides the psychological safety aspect to ensure that people feel comfortable sharing what they did. And that doesn't mean that, like as you mentioned, sometimes someone did do a thing.
Mistakes are going to happen. It comes down to, like, if they're breaking process, if they're intentionally disregarding policies and they're doing things that are known to be unsafe, there's a difference than, I released some code, I didn't know this library was going to be problematic, and then all of a sudden half of my HTTP responses are 502.
Yeah, I once thought I was deleting a bunch of data from a database that lived in staging, except I deleted a bunch of data from a database that was in production. And this database did not have backups.
Uh-oh.
Luckily, we were able to reconstruct most of that. Right?
Okay.
Luckily, it was old data, so it was like I deleted the previous month of data as opposed to the month that we were currently operating in. So it wasn't quite as important of data for day-to-day operations, at least. And I remember when I did that, I felt terrible, and I had to leave. But I left because my coworkers said, "We got this," right?
Yeah.
Because they understood the weight of what I had done and how I felt about that. And they encouraged me to go on a walk. And I did. And I left for like an hour.
Okay.
I walked around the West Village. It was a really nice day that day. And I came back and then I helped fix things, right?
Yeah.
But it was great that we built that kind of culture where my coworkers on my team were like, yo, we got this. It's not the end of the world, but we can tell that you feel really bad right now, right?
Yes.
And that's what the right culture really looks like. And at that point in time, I'd already been I was very senior, in my career. I ran incident management workshops, right? Like I was considered one of the experts at doing this. But having the right culture around me and having my coworkers say, don't worry, go take a break, And then of course we put new guidelines in, or guardrails, I should say, right? We made sure it wouldn't be possible to so simply delete an entire month of production data. Right?
Are you sure? I put little dialogue boxes?
Yes, and I actually did that, right? I took that as my responsibility for having caused that incident, for having caused that problem, was I'm going to go update the tooling we use. I'm going to go write the code to implement those guardrails, to display what you're going to delete instead of just deleting it, to have a, are you sure, to have a mandatory flag you have to type in to indicate what environment you're, is it staging, is it dev, is it prod, right?
Well, those are good rails, because I'll say this. Earlier in my career, I had just gotten into like the seniorish type of roles, and my team lead said, when I broke something, I ran it twice, having worked in a place where there were a lot of guardrails in place that would stop you from having something run twice. And instead, it basically chased its own tail and left itself in an inconsistent state. My response was, hey, I think we should probably put something in to prevent this. And his response to me was, no, just don't be stupid. And I think that that's probably the wrong approach.
Yes.
And I kind of view it as, so we have people who are professional athletes in this world. They are at the pinnacle of physical ability and the fortitude to be there, and yet the word fumble still exists.
Of course.
Because people are going to drop the ball, both figuratively and literally. And I think that if we make that impossible, or try as hard as we can to make that impossible, we'll be in a good spot. But you can't yell at somebody because they dropped the ball. They feel bad. They know what they did. And they're probably going to rewatch that tape 50 times before they finish out the weekend going, I'm never going to do that again. And they're probably going to. But they want to know that they're not going to be chastised for doing it if they have something they could have made better.
And there's also the aspect of, so like I'm a pretty big sports fan, right? Like I watch just about everything. And there's a tendency for fans of a team to blame someone who misses a shot or does something like fumble the ball. But there's also the fact that sometimes it's that the defense is really good. Right?
It's
like
the referee's fault. You know it is.
Sometimes.
Yeah.
But yeah, like even that sometimes, right? Sometimes it really is the wrong call. But I see this, like I watch a lot of soccer.
Okay.
I'm European, so I call it football, but
Won't hold that against you, it's okay.
And you'll see fans get so upset when a player makes a great shot, but then like the keeper blocks it, right? But they get upset at the player instead of realizing the goalie on the other team just did a really good job, right?
Yes. You're invested in your side of the equation. Right.
These systems we work with are all complex. They are all intertwined. Modern computer systems are very distributed. There are so many components at play. Even within single binaries, how many different libraries you might be working with. And this stuff is all this big, difficult to understand mesh. And sometimes you're looking at the wrong component, right?
Yeah.
Maybe you shouldn't be looking at the striker, you should be looking at the goalie on the other team. Right? But yeah, it's all about building the right culture to ensure that people are accepting of each other, that they understand that failures do happen, right?
It's inevitable in some cases.
Yeah, absolutely. Nothing's ever perfect. This is my whole thing is service level objectives, right? Like SLOs, and the whole concept behind SLOs is basically embracing failure, right? That's still my favorite chapter in the first Google book, right? In fact, it's the first chapter after the intro chapter, right? Embracing failure. Site reliability engineering is all about understanding a certain amount of failure is going to occur. Just make sure it's not too much, but be okay. Accept that there's
absorb, respond,
problems.
and yeah. No, absolutely. Because I kind of take it like this, and I think we should probably close on that maybe, is one of the first and simplest tools ever created by humans was probably something sharp to cut with. And I feel like one of the next things that was done was they put a handle on it.
Probably.
because they were tired of cutting themselves. So I think that that's probably where you come into play with, we need to know failure is going to happen, you're going to cut yourself, but that doesn't mean that you just accept it. You should adapt and overcome and make something, a new tool, a better way of doing things to protect the next generation of engineers from making the same mistakes that we did and give them a better place to live in when we're gone.
But also understanding that even if you add the handle, you're still going to cut yourself sometimes.
Yeah, absolutely. Well, thank you very much. It was really great talking to you.
Thank you so much for having me.
Thanks.